Okay, so quite a few things to talk about. Again, since we all know pi, let's make this arc, right? So, how do we know whether this is true or false? How do we know? My favorite thing to do is to say, hey, I am greater than you. I am better than you. Here's the problem with this. You are smaller than this. You do not get to point at somebody. Yeah? The person who is doing the pointing is the person that's taller. The person that's bigger is the person that points to you. Therefore, this is going to be false. Why is it false? Because you are 65. If you're 65 years old and I'm 87, you're not older than me. You understand? You're not older than me. Now, if you want this to be true, this is what's going to have to happen. See that? Oh, that's a different argument. I am pointing to you to let you know that I am older than you. I am wiser than you. I have more money than you. I am whether wider, fatter, whatever. Right? So now the statement is no longer false, but actually this time, this time is actually true, right? Yeah. Now, here's something else. For example, especially I did questions similar to this. What happens when you have someone that doesn't know this is a simple example. Oh, sorry, hold on. Let me give you some perspective there. There we go. There you go. Yeah. All right. So, how do we know if this or this is the larger of the two? We don't know. I mean, as decimals, that doesn't help. The decimals don't help me at all. What I'm going to do is, I'm going to say, hey, I jumped back 2 times. If I jump back 2 times, it means that my denominator has 2 zeros. I take that number without a decimal and place it over that. Now watch this. Let's go over here. Same thing. I jump 1, 2, 3 times. However, what do? That number without the decimal point, we put what? 1, 2, 3 zeros down here. Now, I'm going to change this to a box because we don't know what sign needs to be in there. We don't know that yet. No, here's the problem. 2 zeros, 3 zeros. Both of them need to have the same number of zeros. And you go with the larger one. The LCM of these two will be the larger. Because I can divide this by this without a remainder. Therefore, 2 zeros here, 2 zeros here. If I did this, and I did this, I have 1 zero left. Therefore, no, we're onto something. No, look at this. Oh, what if we now focus on the numerators now? Yeah, no. Here's where it gets even nicer now. 8 minus 8, well, that's 0. However, 7 in the tens place is more than 0 in the tens place. And therefore, I am 870. I am a certain amount greater than you. I am pointing at you to tell you I am greater than you. Yeah? So, you see how decimals turning into fractions makes this a lot easier to do. There are times when the fraction is better to use. There are times when the decimal is easier to use. For example, if you're multiplying any number by 1,000, just jump by that number and the decimal is easier. So for example, let's say I am multiplying 0.513 and I'm multiplying it by 6,000. Well, you just make your life nice because you can split that 6,000 into what? 1,000 times 6. You jump 3 times, right? 1, 2, 3. So now you have successfully multiplied this by 1,000. So now what do you have? You have 513 times 6. And that's it. So whatever your answer is for that, I mean, should be. It should be, right? So yeah, like I said, since we all know pi, let's make this arc, right? Perspective is everything, right? So yeah, it's very important to make that jump between the decimal and the fraction. Very important, because if you can make use of that, then you don't have that issue of identifying the place value and being confused. You eliminate the confusion, you eliminate the second guessing, right? So that's what that's what we're here to do. Okay, yeah. Let's see if there's anything else on my mind. Oh, I have something. No. Here's an interesting part. See, it starts out like this. Starts this way. It also starts this way. But then suddenly you do this. And suddenly it starts to look like that way. Imagine that. Yeah, you see, that's why the series is called what it's called. Since we all know pi, let's make this arc. It's all about how you look at it. So therefore, you have the area of the face being multiplied by what? Now it has a height. If you stack enough of these on top of each other, they start looking like that. Yeah. And I mean, it also works like this too. Alright, so it starts like this. But then somehow something like this. Now mind you, I did not get the perfect circle, right? But you know, yeah. You understand? Of course, the area of this is in fact this, and the area of this face is also this. However, because you also have the added dimension of that right there, then of course think of it like this is the length, this is the width. Length times width is the area. So basically the area of a 3D figure is the volume. And so that is why your area, or let me be more specific, your volume of this 3D figure is always going to be pi r squared h. Yeah. Yeah. Now, there's a lot that can be said about nets. Now, if you have a net, you know the total surface area of whatever figure you are using. So in this case, you have a circle here, and in the middle is a rectangle that once it's folded out, it comes out like a rectangular sheet with one end that has a circle and the other end has a circle, and it's enclosed to form that. Yeah, I mean, I can show better than I can tell, you know, so it looks a lot like now, mind you, something like that. Now, mind you, I'm not 100% super precise, but you know. Yeah. So with this in mind, if you fold this that way, this that way, and lock these circles in, it looks like that. And of course, because this forms a circle, the line that forms a circle is 2 pi r. Therefore, the length of this part that bends this way is 2 pi r. So one part of it is your height, but the other part is 2 pi r. The area of this rectangle here is 2 pi r h. Right? No. Well, the area of one circle is pi r squared, and the area of another circle is also pi r squared. You add both of them, you end up with 2 pi r squared plus 2 pi r h. Yeah. Yeah. You I mean, just in case you struggle with understanding it, don't worry, I did as well. Yeah. But that's the you know, I mean, visualizing is one thing, but having it explained to you is something else entirely. So, what else? Now, I don't know if a lot of people are told this, but think of if you think of that, then 1 over x can also be seen as that. Right? Something raised to the minus 1 times something raised to the 1. And of course, anything raised to the 0 is also equal to 1. Now, if that is true, then what is happening when you want to find just the angle here? Well, you would be finding the inverse sine of that, just like what you're seeing here. But if you do that to the left, you do it to the right as well. And so you would do the same here. Now, obviously, right? Yeah. And so this cancels this, leaving you with just Yeah?